Algebra 2, Chapter 8 and Chapter 9 test preview. We'll be having a test later this week, and so I'm offering some preview exposure to this. We're going to be covering two main topics here, one of which is polynomial functions of degree 3 and greater, and also basic inverse variation problems. Anyway, one, solve the polynomial equation by factoring. So the first thing you look for in factoring is to find a common factor. And if you can see that there is x everywhere in this expression, in this equation on the left side equation. So we're going to have x. We take an x out of 6x cubed. What times x equals 6x cubed? It's going to be 6x squared. Okay, 6x squared and minus 13x minus 5 is equal to 0. So we already know that x equals 0 is one of our solutions, because we set this single x equals 0, the equation is true. And now we have is a quadratic trinomial without just a plain x squared. So here we have a is equal to 6, b is equal to negative 13, and c is equal to negative 5. And I showed many times in class this x method or bottoms up method. So here AC, that's going to be 6 times negative 5 or negative 30. And then B is negative 13. So we ask the question, what two numbers multiplied together equal negative 30, but when added together equal negative 13? So you can just try the different factors of 30. And I think what we go for here is if we put 2 and 15. And why that? Because if we take 2 times negative 15, we get negative 30, and 2 plus negative 15 is negative 13. Then we divide by a, and a is 6. And then we have 1/3. And then on the right, we simplify to negative 5 over 2. So now, we take x plus 1/3, and then x minus 5/2. And those are all equal to 0. But what we're going to do is use the bottoms up method here. So we have x, and we have 3 times x. We have 3x plus 1, and then 2 times 5. So 2 times x, 2x minus 5 is equal to 0. So we already have x equals 0, but also we're going to have 3x plus 1 is equal to 0. And if we solve this, we have, and divide by 3, we have x is equal to negative 1/3. And then over here, we have 2x minus 5 is equal to 0. We add 5 to both sides, we get 2x is equal to 5. Divide by 2, x is equal to 5/2. And so here we are. Those are our solutions. X equals 0, x equals negative 1/3, and s equals 5/2. And really, this can be quite easily graphed in the calculator as well. So we go here, and just for confirmation, we have x I'll just put them in full. 6x cubed, 6x cubed, minus 13x squared, and minus 5x, and some 6. So here we have a 0 at x equals negative 1/3, at 0, and at 5/2. And you can play around with the table view to see where the zeros are too somewhat, but you could pretty well see, I hope, that this is confirmed. Okay, let's go on to problem 2. Solve the polynomial equation by factoring. Again, I invite the viewer to go ahead and work it out by yourself, then play ahead, see if you got it right. Okay, well, in this case, we definitely have x as a common factor, but also there's more than x, because you notice each of these coefficients, 4, -10, and 6 has a factor of 2, so we can pull out 2x. So we have 2x squared minus 5x plus 3 is equal to 0. So if we have 2x is equal to 0, we know x is equal to 0, so that's going to be one of our factors. One of our solutions, x equals 0. And then we have this AC thing we did before. 2 times 3, 6. And then over here, -5. What two numbers add together equal -5, but multiply together equal 6? How about -2 and -3? Then we divide by 2. So we get -1. So we get 2x, x minus 1, and then we put x minus 3/2, and then we go ahead and do the bottoms up. So we get 2x minus 3 equals 0. So x minus 1 is equal to 0. So x is equal to 1. That's a solution. And then we have 2x minus 3 is equal to 0. Add 3. So we have 2x is equal to 3 by 2. We have x is equal to 3/2. And again, we could check using our calculator, as I did in problem 1. Next, problem 3. Basically, you'll be asked a question about a certain what about x-intercepts and what type of functions. Well, quadratic function has at most 2 x-intercepts. Okay, so if we graph the thing, it could look like this. A cubic function has at most how many x-intercepts? Well, that would be 3 x-intercepts. A quartic function has at most how many x-intercepts? 4. A quintic function has at most how many x-intercepts? Would be 5. And a linear function has at most how many x-intercepts? 1. And that's related to the powers of x. X squared, x cubed, x to the 4th power, x to the 5th power, and x to the 1st power. Next, what are all the roots of the following equation? And here you have this equation right here. Again, we have a common factor here, which is x squared. So if we take x squared out of this, we get x squared times what equals x to the 5th power, would be x cubed. And then next we have minus x squared. Then we have minus x plus 1 is equal to 0. So we know that that x equals 0 is our root because we said x squared equals 0. That's correct. One thing we can do now is just look at the equation here, just put it in our calculator. There are a lot of, we could use synthetic division, a lot of things we could do. So x cubed minus x squared, x squared, get over here. We have minus x, over here, minus x, plus 1. And I think that's right. Let's go check to be sure here. Yeah, that's right. So we graph. What does this look like? I put zoom 6. Looks like we have -1 and 1. You can check the table view. Yeah, -1, we have a 0, and at x equals 1. So, oops. So just by graphing x equals -1, and x is equal to 1. Now, I don't know, sometimes multiplicities can be an issue here. I don't think we're being asked about that. So there's number 4. Next, 5. Solve the polynomial equation by finding all real roots. Okay, so similar type of problem. I'm going to just start by graphing this. So we put in our calculator. Oops, that's the wrong one. So we have x to the 4th power minus 18x squared. And we have plus 32. And graph, what do we see? Well, we got a whole bunch of things here. Looks like we have -1, 2, 3, 4. So -4. And then we have +4. 1, 2, 3, 4. So we can just, if we want to, we can just go ahead and figure this out. If we plug in our 0 of 4, we're going to have 1, 0, -18, 0, 32. So we get 1x cubed. 4 times 1, 4. 0 plus 4, 4. 4 times 4, 16. -18 plus 16, -2. Let's see, something looks wrong here. 4 times -2. That'll work out. -8. -8. 4 times -8 is -32. 0. And we also know we have -4 as a possibility. So let's go ahead and bring up this -4. 1, 4, -2, -8. And we don't have any remainder left over. So 1. 4 times 1 is 4. 0. 4 times 0. We have 0. -2. 4 times -2 is 8. 0. So we have x squared minus 2. If we set this equal to 0, and we add 2, x squared is equal to 2. So x is going to be equal to plus or minus square root of 2. So there we have all real roots. Next, 6. Solve the polynomial equation by finding all real roots. I'm just going to go ahead and graph this one. Y equals clear. We have x cubed plus 7x squared plus 14x plus 8 so we have this here. Looks like we could probably see them all here. I think negative 4, negative 2, and negative 1. Let's check our table view. Yeah, negative 4 is 0, negative 2 is 0, negative 1. So, by graphing, x is equal to negative 4. And I'll just put this in set notation. Negative 4, negative 2, and one more. Let me just see what it looks like. And negative 1. So there we go. Next, 7. Solve the polynomial equation by finding all real roots. Same type of thing as before. Go to the calculator. I'm going to clear 4x cubed minus 4x squared minus 5x plus 3. Graph. Looks like we got negative 1, but then we have maybe 1/2 and 3/2. I don't know. But anyway, it looks like negative 1 would be a 0. So if we use negative 1, let's check out what we have here left. So negative 1, we get 4, negative 4, negative 5, 3. So 4, negative 1 times 4 is negative 4. We get negative 8. Negative 1 times negative 8 is 8. Negative 5 plus 8 is 3. Negative 1 times 3 is negative 3, 0. So we get 4x squared minus 8x plus 3. And then we can factor this. So we already know x equals negative 1 is a real 0. Let's go take this one here. We get 4 times 3, or 12, right here. Negative 8, what two numbers multiply together equal 12, but add together equal negative 8? How about negative 2 and negative 6? And we divide by 4. So we get a negative 3/2 and negative 1/2. So we get x minus 1/2, and then x minus 3/2, and that's equal to 0. Then we use our bottoms up method. We get 2x minus 1 is equal to 0, and also 2x minus 3 is equal to 0. And then we add 1, and then we divide by 2. So x equals 1/2. That is a 0, or a real root. we over here add 3. We get 2x equals 3. So working right here, x is equal to 3 halves. So those will be our real roots right there. Okay, next. 8. Find all real zeros of the function. Include multiplicities greater than 1. I'm going to go to calculator again. Because what we're going to do is find, we'll be able to identify, I hope, a value of 0 and then kind of work backwards from there. Okay, plus 3x squared minus 4. And we graph, what do we see? Looks like at -2 and at 1, looks like that's a multiplicity. 1, let's see this. Go to table view. So -2 and 1 are the zeros. So we have x equals -2, x is equal to 1. I think our multiplicity, if you look at our graph, we touch but do not cross the x-axis at x equals -2, so that's a multiplicity of 2. So multiplicity is equal to 2, and then for x equals 1, that's multiplicity equal to 1. So that, where it just touches, that's a double 0. Okay, that's going to be part of how you're scored points to get your correct multiplicities of these zeros. Next. Find all real zeros of the function, include multiplicities greater than 1. Here we have go to the calculator again. Enter x to the 4th power minus 6x cubed plus 6x squared plus 4x squared, excuse me, plus 6x minus 5. And we graph, what do we see? Looks like we have -1, 1, and 1, 2, 3, 4, 5. Let's go over here. -1, 1, and 5. And this one here at 1 has a multiplicity of 2. So we have x equals -1. That's a multiplicity of 1. We have x equals 1. That's a multiplicity of 2. And we have x is equal to 5. That's a multiplicity of 1. And all the multiplicities added together, which is 1, 2, and 1, that has to add up to no more than 4. Okay. All right. Okay, number 10. How many real zeros does a function have? How many real roots or real zeros? Let's go ahead and put it in the calculator. Clear out. So we have x to the 4th plus x to the 3rd power. This is a quartic function. And then we have minus 5x squared plus x minus 6. X minus 6. Graph. I'm seeing two real zeros at x equals -3 and x equals 2. So we will say 2, see if I can write it a little more legibly, 2 real zeros are roots. Roots and zeros being synonymous. Also x-intercepts, that'd be another synonym. Next, 11. What are all the real roots of this function here? Again, go to that calculator. We will clear. We have 3x cubed. We have plus 10x squared. Minus 44x plus 24. And graph. Okay. I see 3 right here. Or what they're saying, what are the real roots? Well, looks like 2 of them are right on the line. Let's go to, so we have a at -6 and at 2. So x equals -6, x equals 2. We know those are 2 of our real roots. Okay, let's go ahead and figure this out, what our remaining real root is. We put -6 out here, 3, 10, -44, and 24. So bring down to 3. 6 times 3 is -8. 18. I said -8. I'm saying -18. Let's just go ahead and write it like this. We'll just do it like this. -18. Get -8 here. -6 times -8, that's going to be positive 48. -44 plus 48 is 4. -6 times 4 is -24. So we get 3 x squared minus 8x plus 4. So 3, -8, 4. We're going to put x equals 2. So we'll bring 3 down. 2 times 3 is 6. -2. 2 times -2 is -4. So we get 3x minus 2. We set that equal to 0. So we have 3x equals 2. So working to the right, we have x is equal to 2/3. Okay, is that consistent with what we saw in the graph? I hope so. I think it is. Graph. Yeah, x equals 2/3. Looks good. So those are all the real roots. Okay, 12, constant variation. Here we're getting into another section of the test, had to do with inverse functions. Chapter 9, constant variation. Here's a direct variation example, y equals 3x. An inverse variation example, y equals 2.5 over x. These numbers here, 3 and 2.5, these are called constants of variation. So this 3 is a direct variation constant. This 2.5 is an inverse variation constant. 13, write an equation relating to the variables, then use your equation to solve the problem. If y varies inversely as x, so we just write this out, y is varying inversely as x, right? And so a, our constant variation, y equals our constant variation a over x. So we can go ahead and plug in x equals 16 when y equals 0.5. So here we have 0.5 for y is equal to a over 16. And so we cross multiply. We have a is equal to 0.5 times 16, which equals 8. So our equations would be y is equal to 8 over x. And now if we find y when x equals 3.5, so y is equal to 8 over 3.5. And I'm just going to put that in the calculator. Eight divided by 3.5, 2.28, 2.286. That's a weird one. And you can tell if it's correct, because we multiply that by 3.5, we should get 8. Let's go ahead and do that. Times 3.5, do we get 8? Yes, we do. Check. 14. Write an equation relating to variables, then use your equation to solve the problem. Kim lives in a suburb and drives to work city. The time t in hours it takes her to get to work varies inversely of average drive GPS in miles per hour. So we would write it like this. Time t in hours varies inversely. So I'll put a over s. And when she averages 20 miles per hour in heavy traffic, it takes her 1.5 hours. So t is 1.5 equals a. Okay, 20 miles per hour. A is equal to 1.5 times 20, which equals 30. So our equation is going to be t is equal to 30, our constant of variation, over s. And then if we average 50 miles per hour in light traffic, t is equal to 30 over 50, which equals 3/5, or 0.6. And how much time is in hours? That's going to be hours. And in minutes, let's see, that'd be 0.6 times 60 would be 36 minutes. Okay, next. Examples of direct and inverse variation in table form. So that's pretty simple. What you have is this first one here. You're going up. S is going up with t. So this would be a possibility of direct variation. And you can find out what that is. There's like a slope. In this one here, on the bottom, you're going up as y is going down. This is an example of inverse variation. And you can find what the constants are, constant of variation. Here you get S equals 4t for direct variation here, you'll get 12 times 60. So y equals 60 over x. You can see why that's the case. Right, if we take, that doesn't look right. It's going to be more than that. It's going to be 12 times 50, 600. There we go, that looks better. So our constant variation here is going to be 600. And then we could try to figure out, use this equation to figure out anything we want to find. If we want to find, plug in for 10 for x, what are we going to get? Well, we'll get 60, right? If we plug in 100, we would get 6, okay? Next, 16. What are the horizontal and vertical asymptotes for the following function? You can do this in different ways. You can go ahead and divide out by this. You can graph this in the calculator, see what it looks like. Here, our horizontal asymptote is going to be found by taking the highest power in the numerator, dividing by the highest power term in the denominator. So we're going to get 5 over 2, or 2.5. So that would be y for f of x equals 2.5. As far as a vertical asymptote, we have a vertical asymptote where the denominator is equal to 0. So if we set 2x plus 3 equals 0, and subtract out 3, we have 2x is equal to negative 3. So we have x is equal to negative 3 halves. This is our, that's our vertical asymptote. This one right here, y equals 2.5, that's a horizontal asymptote. And then there are other ways of doing this too. You can take this, you can graph this in the calculator, see what it looks like to confirm. So if we go here, we put 5x minus 2 here. And then we put in the denominator 2x plus 3. Graph, what does it look like? It's really hard to see here. If we went to a second format and used grid line, we would see more. So we have our horizontal asymptote is 5 over 2. Our vertical asymptote is negative 3 over 2. We can do this thing where we take this 5x minus 2 and we can take and make this thing 1. So if we multiply by 0.5 over 0.5, we would have 2.5x minus 1 over x, and 3 times 0.5 is going to be 1.5. So we could go like this, put our negative 1.5, 2.5 minus 1, bring down the 2.5, and 1.5 to 2.5, that's going to be negative 3.75. So we get negative 4.75. So this is going to be our our K value, which tells us what our horizontal asymptote is. And then this will be our stretch thing here. But if we set this x plus 1.5 equal to 0, okay, we're going to have x is equal to negative 1.5, which is what we saw earlier here. Okay, next, 17. Membership in a fitness club costs $45 per month plus a one-time registration fee. So what that's going to look like is this. I'll just show you what it is. Your membership in the fitness club is $45 plus one-time registration fee for $102. So you, just to join, you got to pay $45 up front. Plus, for your average, you take 102 divided by x. So that's going to be a function of our average cost per month. So let's see, equal average cost, average monthly cost. And then if we, for 6 months, what is the cost going to be? Average cost 45 plus 102 over 6. Okay. $45 plus 102 over 6, $62 per month. So these will be our figure out here. Okay, next. 18, identify the vertical and horizontal asymptotes of the graph of this. So what we have is our center is going to be h comma k, which is going to be h is equal to 3, k is equal to 1. So 3 so vertical asymptote is x is equal to 3. And then we have k equals 1, so we got 1 right here. So horizontal asymptote x, or so y is equal to 1. So that's what we have. X equals 3, vertical asymptote. Y equals 1 is our horizontal asymptote. And what does this look like? Well, we have our a value is negative 2, so normally it'd be at 1. So 2 up there, we're going to go reflect about the x-axis. So we're going to stretch like this. So here we go. So the graph is going to look like this. And then the other side, we go down to up to here. And we're fortunate to be able to graph this in our calculator. So we come here. We have negative 2 times. We have 1 over x minus 3. And we come out here, we put plus 1. And what does that look like? Okay, we got our vertical asymptote at x equals 3, or horizontal asymptote at x equals, at y equals 1. And so that's what the thing looks like. Yeah, that's what we've sort of stretch right there. Yeah, so it looks good. Okay, last one. rewrite the function in the form g of x equals a times 21 over. So I'm going to go ahead and we're going to rewrite it in this a form. And to do that, I'm just going to synthetically divide. We have x plus 2, so our 0 is negative 2. And then we have 3 and 8. So we're going to bring this down. 3. Negative 2 times 3 is negative 6. So we get 2. So g of x is equal to 2 over x plus 2 plus 3. And then, so we have our center at h equals negative 2, 3. So we go to negative 2. And y equals 3. Okay, our vertical and horizontal asymptotes. And then we have a vertical stretch factor of 2. So we're going to go up 2 here. And then we have down 2 here, down 2 here. It's very easy to graph to see if this looks correct, and it is. And then last we have domain and range. Just to save time, I'm just going to use the interval notation. Our domain is going to be negative infinity to x equals negative 2, union negative 2 to less than infinity. Our range is going to be greater than negative infinity, less than 3, y equals 3, union 3, comma, infinity. So anyway, that's it. We're going to have a couple days to go over this and make sure you understand everything well. Good luck, and thanks for viewing.